Hello students, once again welcome to the LG Institute of Engineering and Technology. Let's start with the course Mathematics 1, and today's chapter is Applications of Partial Derivative. In this chapter we have today's topic is maximum and minimum values. That means we can say that extreme values. So let's understand these, what is the maximum and minimum. So let's start with the first basic concept of extreme value. We can say extreme value or maximum or minimum. So the point at which given function is either maximum or minimum is known as a stationary point. So what is stationary point? The point at which function attain maximum or minimum value is known as stationary point. The value of function at stationary point is known as extreme value. That means maximum or minimum. Okay. Now we have working rule to understand or to find the extreme value of the function. That means these are the working rule, and by using this rule we will solve the example. So first step, for the given function f of x comma y, we will find del f by del x and del f by del y. Second, for maximum or minimum values, that means for extreme values, we will take this two derivative is equal to 0. So we have two different equations, and by solving these two equations simultaneously, that means together, we will find the points, that is solution of these two equations, and these points are known as stationary points. So if there is a question in examination that finds stationary points, so you have to do this three step. First find derivative, then take derivative is equal to 0, so you will get two equation, and by solving these two equations together, that means simultaneously, you have a solution in the form of point, and that points are known as stationary points. Okay. Now next step, step number 4, find the value of r, s and t. That means r, we know that differentiation of given function partially with respect to x 2 time, s, that means differentiation of given function 2 time, that means 1 time with respect to x, 1 time with respect to y, partially 1 by 1, and t, that means differentiation of given function partially with respect to y 2 time. Now after getting this r, s and t, find rt minus s square, r into t minus s whole square at point that we have find, that means stationary points, or separately one by one we will check the following condition. If after checking the condition for one point, then we will apply second point, then we will apply third point, and one by one on the rt minus s square. So first we will take this AB for understand better how and when we can apply this following condition. Number 1, if rt minus s square greater than 0 at AB, then we will write function is either maximum or minimum. Okay, so at given point this rt minus s square is greater than 0, then either function either maximum or minimum. Then we have to check only r, then we have to check only this r. And if r greater than 0 at point AB, same point, at same point, then function is minimum. Okay, keep one thing, this you have to pay attention, pay more attention. If r greater than 0, then function is minimum at point AB, because we are taking only AB point right now. Okay, and minimum value of the function is getting after putting the value point AB in the function, that means f of AB. If r less than 0 at AB, if not greater than or less than 0, then function is maximum at AB, and maximum value of the function is getting that put AB in the function f of AB. But if r is equal to 0, then at point AB, then nothing can be said about the maximum or minimum. Okay, so if rt minus s square greater than 0, then we have to check r. Okay, only r at same point, and either of these three, any one is applicable. Okay, but if Same point at AB, RT minus S square is not greater than 0. That means if less than 0, then that number 2 we have. That RT minus S square less than 0 at AB, then function is neither maximum nor minimum at AB. And that point, this point is known as saddle point. And if RT minus S square less than 0. Okay? And if RT minus S square greater than 0 at point AB, then nothing can be said about the maximum or minimum. That means we have no any conclusion about the function. We have to do more process and more simplification about the function. So these are the basic step of or how to solve the example by this working rule. Okay. Now let's start with the example and understand how that step we gonna use in example. So find the extreme values of the function. This function is given by this. If any, if there are any extreme values, then we have to find that is maximum or minimum value. So start with the solution. First we will write down the function. So we have given function f of x comma y is equal to x cube plus 3xy square minus 3x square minus 3y square plus 4. What are the steps? Let's have a look on the step. Steps are find the del f by del x, that we know that with respect to x derivative. So we have 3x square, derivative of this is 3y square and derivative of this is 6x, and 0, 0 because we are differentiating partially with respect to x, treated y as a constant. Now find the del f by del y. So differentiation of x cube is 0, differentiation of this term with respect to y is 6xy, and differentiation of this 3x square is 0, and differentiation of this is 6y, and differentiation of 4 is 0. Now after finding these two derivatives, step number 2 is for maximum or minimum value. That means for extreme values, take this 2 is equal to 0. That means del f by del x is equal to 0 and del f by del y is equal to 0. This is step 2. So del f by del x is 3x square plus 3y square minus 6x is equal to 0, and second 6xy minus 6y is equal to 0. Okay. Now by solving simultaneously these two equations, that means you have to put the value of this into this or this into this, or by elimination method. Whatever it is applicable, you can apply. There is no any fixed cross method that you have to use only that method. So in this example, you can see if I take common from this equation 6y, okay, 6y, so we have x minus 1. And we can say that this into this is equal to 0. That means either this equal to 0 or this equal to 0. So we have y is equal to 0 or x minus 1 is equal to 0. That means x is equal to 1. So from this equation, we have these two value of x and y. This is different value. So this is not a one point. Keep one thing in your mind. And by taking 3 common from this equation, we have this equation, say equation number 1. Now we have to solve simultaneously. That means we have to put y is equal to 0 in equation number 1, and we will get the value of x. So at y is equal to 0, we have x that become 1 point. Same way, by putting x is equal to 1 in equation number 1, here and here, we will get the value of y that becomes different point. Okay, so we have to take one by one. So by putting y is equal to 0 in equation 1, and what is equation 1? This one. I just write down this equation because we have a limitation that we cannot go back, that's why. So now put y is equal to 0 in equation, so we have x square minus 2x is equal to 0. By taking x common, we have x minus 2. So x is equal to 0 and x minus 2 is equal to 0, that means x is equal to 2. So this value x when y is equal to 0. So we have point x0, y0, x2, y0. So points are 0, 0 and 2, 0 because first we write down x then y. So these are the stationary points from y is equal to 0. Now same way we have x is equal to 1. So by putting x is equal to 1 in equation 1, and what is equation 1? We know that. So put x equal to 1 and 1 here. So we have 1 y square minus 2. So we have y square minus 1. By factorize this, we know that y minus 1 and y plus 1, okay, is equal to 0. That is y minus 1 is equal to 0 and y plus 1 is equal to 0. So y is equal to 1 and y is equal to minus 1. So this value of y is from this by putting x equal to 1. So x1, when x is equal to 1, y is equal to 1, and when x is equal to 1, y is equal to minus 1. So we have two stationary points, 1 1 and 1 minus 1. Okay, so we have these four stationary points. This is our step number 3. Okay, now we have step number 4 is to find r, s and t. So r, that means differentiation of that del f by del x again with respect to x. So we will get 6x minus 6. You can pause the video, go backward, and you can check. Okay, now find del square f by del x del y, that means s. That means differentiation of del f by del x with respect to y, or you can differentiate del f by del x with respect to x. Both will be same because by mixed derivative theorem, which is 6 pi. Same way, del square f by del y square. Okay, so you have to use not and pen. So whenever you are watching this video, use not and pen and writing down so you can see the steps. Okay, and with respect to y, second time is 6x minus 6. Now, after getting the value of r s t, we will find rt minus s square as we have seen. So r into t minus s square, that means whole square. Now we have these stationary points. So we will start one by one. First we will take 0, 0 point. Then second point we will take 2, 0. Third point we will take 1, 1. And fourth point we will take 1, minus 1. So let's start with the point first. 0, 0. Ready? X, y is equal to 0, 0. So we will put this point into rt minus s square. So we have rt minus s square is equal to, this x is 0, this is 0, so minus 6, this here, and y is 0, so this term is 0. Minus 6 is 36, and which is greater than 0. So as we have conditions, and first condition here applicable that rt minus s square is greater than 0. So we can say that given function is either maximum or minimum. So now for proper, now we have to check that given function is exact maximum or minimum exactly. For that we have to check r only. Okay, as we have seen in A, B and C. So we will check r. That means here r is given 6x minus 6, and we will put this same point 0, 0. So this is 0, so we have minus 6. That means r less than 0. And as we have seen this one, as we have seen, if rt minus s square greater than 0, okay, and r is less than 0, then function is maximum. Okay, so this is our steps. You have to just check. And so r less than 0, so we can say that function is maximum at point 0, 0. So at this point function is maximum. Now this is just we have checked, or we have decided that at point 0, 0 function at a maximum value. Now function at a maximum, but what is the maximum value? For that, as I told, we have to put this 0, 0 point in the given function. And what is the given function? Given function is this: x cube plus 3xy square minus 3yx square minus 3y square plus 4. This is our given function, and we have to put 0, 0 in this function. So we have f maximum. Okay, that means maximum value of f 0, 0, 0, 0. So we have final answer is 4. This is our maximum value of the function at point 0, 0. Same process, same steps, this same step we will do for this point 2, 0. Okay, so for that just I am writing rt minus s square again. So you no need to go backward. So rt minus s square. Now we have point this and we are going to use 2 comma 0. So 2 comma 0. Put in rt minus s square. So x value of x is 2. 6 to the 12 minus 6. 6 to the 12 minus 6 and y is 0. So this term is 0. 6, so 36 which is positive. 36 positive, so we know that we have this condition. Okay, rt minus s square is less than or greater than or whatever. Okay, so now this time we have rt minus s square is greater than 0 again. Okay, so function is either maximum or minimum, and now we will check r, and here r is what is r? 6x minus 6 is our r. Okay, we will put this point 2 comma 0. So 12 minus 6, so 12 minus 6 is 6 and 6 greater than 0, that means function is minimum. Yes, at point 2 comma 0. Now function is minimum, so we have to find the value of function at point 2 comma 0. So we have this function and now we will put this point to the function, so we will get f minimum because function is minimum at point 2 comma 0. So 2 cube, y is 0, so this term is 0. This 2 square and this term is 0 and 4 as it is. So 8, this 4 3s are 12 and plus 4, so we have 0. This is the value of function minimum value. Okay. Now we have third point 1 comma 1. So for xy is equal to 1 comma 1, we will put in this rt minus s square here. Okay, so 1 1, value of x is 1, so 6 minus 6 is 0, this is 0, and here y is 1, 6 into 1 6, 6 square is 36 and minus as it is, so we have rt minus s square is minus 36. And as I told, if rt minus s square is less than 0, then we can say that rt minus s square is less than 0 at point, we can say that function is neither maximum nor minimum. No need to check r and anything, just that point is known as saddle point. Okay, so we will write down this step, that function is neither maximum nor minimum, and point this 1 1 point, because we are checking 1 1, so 1 1 point is called the saddle point. Okay, so these are the 3 points we completed. Now last point is 1 comma minus 1. So we have x, first again we are writing rt minus s square. Now we have these 4 points. Now this time we are using 1 comma minus 1. So x is 1, so this is 0, and y is minus 1, so minus 1 into 6 is minus 6 per whole square is 36, so minus as it is, again this is less than 0. That means what? Function is neither maximum nor minimum, and this point is also saddle point. So these are the steps of getting extreme values of the any function. Now you will think that this step is compulsory, that we have to check each and every point like this. No, we can check all these 4 points directly by this table also. Okay, so no need to write down all these steps for each and every point. Okay, so direct after getting rt minus s square, you can write this table directly. Okay, so write down only point here, all the 4 point or 5 point or whatever the point what we have to write down. Now we have to put the point in rt minus s square and check, and in r check. So we'll get this conclusion table, and we can write this table in examination also. So no need to write down all the steps. So these are the steps and how we can solve extreme value, how can find extreme value. Okay, now one more example to understand better. Now in this example we will not use that each and every step, we will just use that table. Okay, so example is find extreme value of sine x plus sine y plus sine x plus y. How this example is different from this? There is no change in any solution, but just changes will be when I'll tell you. First write down f, then find the derivative. We know the partial derivative. Okay. Now for extreme value, take this both is equal to 0. So we have this equal to 0 and this equal to 0. Say equation number 1 and say equation number 2. Now by equating equation number 1 and 2, as I told, where is the change? Change is here to find these stationary points. Other than that, there is no change in example. Okay. So by equating these two equation, we can cancel out these two terms. So we have cos x is equal to cos y, and by taking inverse on both sides, we have x is equal to y. So we have this one equation x is equal to y. We have to take as a spare. Now we will use this x is equal to y in either of this equation. We can use in either of this equation. So I will put y is equal to x in equation number 1. So that x is x and that y become x, so cos x plus cos 2x. Keep one thing in mind, this cos x plus cos 2x not become cos 3x. Okay, this is trigonometry. So now we can take this to the right hand side, so minus cos 2x, and minus cos 2x is written as pi minus 2x or pi plus 2x, as we know the quadrant system. Okay, so pi is here, minus is here, plus is here, and in both the quadrant cos is minus because all S, T, C. Okay, in both these quadrant cos is minus. So we have this. So by using this one, first this, by cancel out this cos, x is equal to pi minus x, and by using this equal to this, I cancel out cos, we have x is equal to pi plus 2x. By solving this and by solving this, we have this minus 2x on the left hand side, so 3x is equal to pi, and plus 2x on the left hand side, so minus 2x plus x, that is minus x is equal to pi. So we have x is equal to pi by 3 and x is equal to minus pi. This is the value of x that we have to put in this previous obtained equation. That means y is equal to x. So x is equal to pi by 3. So y is equal to pi by 3. So this is 1 point. And same way, x is equal to minus pi, y is equal to also minus pi. This is second point. So we have stationary points. After getting stationary point, we will find the value of r, s and t. That means second order derivative of that we have already find del f by del x and del f by del y. After getting RST, we will find RT minus S square. So we have RT minus S square. So this is R into T minus S whole square. Now, as I told, no need to apply one by one points. We can use directly table. So first point, second point, if we put pi by 3 in this equation, we will get RT minus S square 9 by 4, which is greater than 0. If RT minus S square greater than 0, so we can say that given function is either maximum or minimum. Then after we check R, here R is this R is this one, first bracket. Okay, so R is negative because both terms are minus, that's why. And we have to put pi by 3 here and pi by 3 plus pi by 3. So 2 pi by 3 sine pi by 3, that means sine 60, root 3 by 2, and same way here. So R is negative and R is negative, so we can say that function is maximum. And maximum value is obtained by putting this point pi by 3 to the function, given function f of x comma y, and we will get 3 into root 3 by 2, and then you have to show that that process you have to show f maximum is equal to, okay, we have the function sin x plus sin y plus sin x plus y. So you have to put the value of x and y here, and by simplifying you will get 3 root 3 by 2. is our f maximum. You have to show this process. Okay. And at minus pi, rt minus s square is 0, as we have seen in that working rule. If rt minus s square is 0, so no need to check r and anything, no conclusion. We can say that function is neither maximum nor minimum. There is no conclusion. We cannot say saddle point, everything, nothing we can say. There is no conclusion about the function. Simple. Okay. So this is our final example, and these are the some practice example for you guys. You have to do practice, and as I told you, more practice will make you perfect in that topic. So keep practicing, and we will see you soon with next topic. Thank you very much. Thank you for watching video.